All right, well, welcome to the Research and Scientific Software meeting. I know a couple of our core members, Dan and Greg, are out on vacation this week. Hey, Marvis, how are you?
I'm fine.
Good to see
Good
you.
afternoon, sir.
Sorry?
Good afternoon. I'm fine, thank you.
Good. I'll throw the minutes in the chat here. You may add your name, not add your name. Everyone's welcome. I don't know if we've, so since a couple people are new here, I'll just introduce myself. I'm Sean Goggins. I co-chair this committee and or this working group, I think we call it. And today we have focused on research and scientific open source, which is distinct from university open source, kind of takes the perspective of the scientist instead of the perspective of the university. That's sort of what distinguishes this group from the other group that does this kind of work in CHAOSS or similar work. And the agenda item, I have one agenda item today, but you're always welcome to add your agenda item here. And Alvin, I'll let you introduce yourself.
Oh, okay. My name is Alvin. I'm currently a software engineering intern at Red Hat. I've been working on integrating an 8-knot chatbot, basically to help analyze and suggest graphs to users.
Which is basically like it's kind of part LLM, right?
Yeah.
Very cool. Very cool.
Mhm.
Marvis, welcome.
Okay.
You can introduce yourself if you want.
Oh,
Yeah,
me?
you know.
Okay. My name is Margaret Wondikom. I'm from Nigeria. So I'm into software development, front end, and I recently joined the CHAOSS. So
Welcome. When it
thank
sure, when it comes to front end work, particularly for software in CHAOSS, the most dynamic environment is the one that Alvin's working on, the 8-knot project, which leverages Augur data to create beautiful pictures and things. Have you seen 8-knot?
Sorry, I don't understand.
So let's see. So I'll just show you briefly what 8-knot looks like. So this is the 8-knot project, and it lets you search for anything you want. So CHAOSS is the default. And like you click repo overview, you get like these kind of nice little pie charts about languages. You can look at scorecard data here.
Okay.
Uh, yeah, so that's 8-knot. I just wanted you to see what it was. So I'll just throw this URL into the notes, and then if you want to look at it later, you are welcome to do that.
Okay, sir. Thank you.
Yeah, no problem. And then it's at https://aspen/8knot. That's where the source code is for that. It's a dash plotly architecture, so very dynamic and much more easily modified and made beautiful when compared to some of the other visual representations available in CHAOSS. Like Augur's front end has some visualizations, but they're nowhere near as beautiful and dynamic as the ones that 8-knot has. Yeah, so I had one thing. You're welcome to add anything that you want to talk about here under the your agenda item here thing. Our two of our core members, Dan Katz from Illinois and Greg, oh, now I'm embarrassed. Greg Watson, thank you, Sean, from the Oak Ridge National Lab, participate in this good deal. And so they're on Greg's got a training today, Dan's on vacation. So we have a kind of a lighter group. And I probably scared people off by telling them that Dan and Greg wouldn't be here in the chat on Slack. But one thing I had to share is the last time we talked about some computational modeling work that my research group here at the University of Missouri is doing. And that work is focused on creating models of classified open source projects. So we're using CNCF and Apache Foundation projects, which have different ways of putting projects into buckets related to the lifecycle maturity of those projects, which I'll explain in a minute. And when they do that, they give us sort of with all of the data, the rich data that Augur has, we have an ability to say, okay, we know that these 2,000 repositories from Apache and these 800 repositories from CNCF are in specific categories, and of the two or three categories that each has. And so we the goal is to try to help other projects understand their life cycle state by giving them something sort of at a summary level that they can compare their work to. A lot of times what people do with CHAOSS metrics is they will just create, like use a dash plotly or a 8-knot dashboard, look at a few projects they're familiar with, compare those projects to a project they care about, that's perhaps their project, and sort of get a sense of how they sit relatively speaking. But that's a very granular, like repository level comparison. It's helpful, but it doesn't provide kind of a wide view of how to understand projects. And so what we're doing with this little computational modeling project that my group is undertaking is saying, okay, let's take this larger bucket of projects and try to understand how that bucket functions with regards to the how those buckets sort of fit the projects that you're interested in. And so in our experiment, which I will switch to now, what we did was we did the CNCF classifications, the Apache classifications, and then we also added labels derived from Nadia Egball's 4 categories from her book, Roads and Bridges. I don't know if you're familiar with that, Marvis or Elvin.
I don't think so, no.
Okay, let me just throw that. It's available because it was funded by the Ford Foundation, and it's a book. And in that book, she basically describes 4 principal categories. And I'll put that here, and I'll also throw it back into our notes so that you can find it later. Sorry, I put it in the notes while I was talking here, just so I don't forget about it. So, and I'll explain those categories, those 4 categories, and the 5th category briefly. So then what we did was we took these computational models, which are technically, or sort of at a very detailed technical level, stored as what are called pickle files. I don't know if either of you are familiar with pickle files. .pkl files are just ways of storing the results of a computational modeling activity so that you can then use those models to classify things that were not used to create the model. So what we did is we took projects that are under the general category of the United States government. And so all projects, we have actually all of the major open source projects that are in the US government here and in our Augur database. And so what you see here is there's an 18F collection and a Department of Veterans Affairs, cloud.gov, and there's like 30 other collections. And what I did here is, so for each repository, we scored it using the Apache model, the CNCF model, and then we gave it a Nadia score. And each of these scores, like 100 would be considered the most mature, and 0 would be considered the least mature in each. And then when we combine the scores, sort of the combined is this number, and then the confidence is this 100 over here. And I'll explain now how we got to those. So for CNCF, the score is like, if it's a sandbox project, that's the first category, it gets a 0. Incubating, it gets a 50. Graduated, it gets 100. Apache has an incubating and graduated category. So Apache uses 2 categories instead of 3. And so we assigned 0 for incubating and 100 for graduated. And then Nadia's categories, we worked with and I'll explain who these folks are in a minute. A longtime CHAOSS member, Remy DeCosmaker, is the head of open source at the Department of Health and Human Services Medicaid and Medicare group, which is a fairly substantial budget in the US government. So it has a lot of resources, a lot of projects, and they are in the US government leading the charge, frankly, to understand and actually manage open source software. So before Remy's group, there really was not a comprehensive way of managing open source in the US government. And so for the last 3 years, Remy has been doing that. So the combined score is basically, we take the Nadia, the Apache, the CNCF, and we add them up, and then we divide them by the total number of categories we're using. This abstract formula kind of gets us there. That abstract formula is less useful than looking at that from a categories to scores perspective. So here are those same categories from the previous slide. And so in an example, let's say we have something that is classified as CNCF incubating, which is actually I did that wrong, because CNCF incubating is 50. Apache is 100 and Nadia is a club, so that's 70. Average score 75, and then the confidence is basically how aligned are each of those scores with the others. So we take 100 minus, we just category. What this is doing is it's taking the absolute value of the difference between A and B, B and C, and A and C. So we're just calculating the differences between the scores compared to each other, dividing by the number of scores we used, and our confidence for this example is 67. Does that make sense, how we got there? Marvis, is that making sense to you?
I'm just getting used to it.
It's okay. It's a bit mathy. Like if you weren't a computer science major or something, I realize it's a bit mathy. So sorry about that. And then these are just a few more examples of the same calculations here. And so this is actually, it provides a fairly, we think a helpful indicator of the confidence scores. And right now we're validating 2 things. We're doing some user studies to understand how to present this information in a way that's the most consumable for humans. And we're also validating the accuracy is the wrong word because that's a technical word in these models. We're validating sort of the human legitimacy, I suppose. So we're having people who are familiar with these projects that are listed here, the government projects, look at the scores we generated for them and tell us what's wrong, what's close, where they think it should be if it's not there, so that we not only have internal validation from the models we use to generate them, but also external validation from folks who understand what these projects are. So those are the fundamentals of what this effort is. And sort of this is, of course, the scientific. So this is a research project, a research software project that we're doing, and it's centered on CHAOSS metrics. Most of what we talk about in this group is not this. Most of what we talk about are scientific projects that are not related to CHAOSS. But here, I think it's just an example of trying to combine everything. So yeah, that sort of covers what we're talking about. Any questions? Well, thank you for listening to my TED Talk.
Yes, sir. Thank you.
So if there are any questions, are there any other agenda items that anyone wants to cover? Well, this could be a very short meeting then, which is okay. It's summertime and we do periodically have these projects that we do periodically have calls on really all the working groups where there aren't as many people here. And I think this is our week on this group for not having a lot of projects here. Not having a lot of people. Well, if you all don't have anything else, that sort of that's the end of the agenda that I have. So I think I can give you back like a half an hour of your time now if you'd like.
Oh, yeah, I don't think there's anything from my side.
Okay. Thank you both for being here. We do often have many more people, so please come back. And I'll talk with you in a couple weeks.
All right, thank you.
All right, thank you. Bye.